Hello, welcome to AI Examples. In this video, we will discuss kNearest Neighbours. Let's start and state the problem first. Let's say we have a data set which is labeled and the elements of two classes. The first class is represented by the blue dots on the graph, and the second class is represented by the red dots on the graph. So now we want to add a new element to the data set. We want to know which class does this element belong to. kNNs, k-nearest neighbours, can answer this question. First, it picks out the kth nearest neighbour and calculates ratios of the neighbours from each class. Then the new element is classified to the class with the highest ratio. So simply, the most often occurring class is picked for that new element. Now we see this algorithm has the parameter k. Does this parameter affect the predictions, and how can we define the optimal k? So let's consider an example where k equals 3 and the two nearest neighbours are red and there's one neighbour that is blue. So we then label that element as red. So let's do k equals 5. We notice the circle here now has 5 elements and the two nearest neighbours are red and 3 are blue. What should we label this? We should label it as blue. So k can dramatically affect predictions, and in general, the bigger the k is, the more stable the predictions are. But how do we know the minimal value when the predictions become stable? How do we pick the optimal value k? Unfortunately, there's no straightforward explanation or algorithm to find the optimal value, but here's some advice. First, the value shouldn't be too small, so it's not affected by these outliers, and k equals 1 or 2 is probably a bad choice because the new element can be located to like an outlier, single outlier near to the element. The second is you can find the value by experiment. You can try different values, test different values, and use cross-validation to estimate how good the predictions are. Set the example. We'll choose the n with the highest accuracy. So in our example with k and n, we test n different values for k using cross-validation. We estimate the accuracy for each value for k and pick the value with the highest accuracy. So let's consider another example. Let's say k equals 6 and the three neighbors are blue and 3 are red. Which one do we choose, blue or red? We can either choose randomly or employ a weighted kNN to make the prediction. Weighted kNNs considers the impact of a particular neighbor to the final prediction. Each neighbor is assigned a weight. Weight is a function of distance, so that the more distance there is, the less the weight. And then the ratios are calculated for each class, and the final prediction is made based on the ratios. The class with the highest ratio is picked for the new element. This is the end of the video, and I hope you enjoyed it. Thank you for listening.